So, good evening to all of you wherever you are. I hope all of you are safe. So, structures in C. Hmm, what I can say about structures in C? Structure, let's start along with the definition. Structure is a secondary data type, right? There is a pointer, which is a secondary data type. There is an array, which is a secondary data type. This is the third one. A structure is a secondary data type. But more than that, it is a user defined data type. Why it is a user defined data type? Is because uh, we are creating a data type the way we want, the user wants, right? Because user may need some unique data type in which you can store variety of information. Now the question arises is for beginner. This question always arises: is there any need of a structure? Because after all, structure is a collection of no similar or dissimilar elements. Now, why there is a need of a structure? Now, daily, suppose these days, let's take the current situation. These days, everywhere in the media, print media, TV media, and internet media, everywhere. Okay, for last I think 5 or 6 months, we have been reading that Corona COVID 19, right? And there is a news, okay, in the newspaper. There is a news like, okay, these are the, this is the this is the number of new patients found today. This is the number of discharged patients. These are the number of deceased in Maharashtra, or disease in Uttar Pradesh, disease in Kerala. I mean, some kind of descriptive information is there, right? Descriptive information is there. But if you don't want to read that, no descriptive, because it is again creates a confusion, and it takes a lot of time as well, and in a summary you don't get anything. So there might be some tabular format is there, right? So the name of the state and the total number of patients found today, then total number of patients discharged today, total number of deceased, that is casualties today, uh, cumulative numbers in that state from the beginning, and what some kind of data is there, okay, percentage kind of data, right? So that table it gives you that the whole picture. The table gives you whole picture. So same tables you will find everywhere in your life. Okay, if you open your notebook, there is a table like, I mean, not notebook, your journal, if you can. Okay, on the journal, your college journal. Okay, that journal there is one first page is there. Okay, like serial number, the name of the experiment, date of some kind of submission or kind of thing, remarks or sign, some kind of thing is there, right? So that is a table. Table gives you whole information, right? Uh, there is um, there are tables in the about weather in your city or in various cities in India, right? There is a tabular format during rainy season where in which cities how much rainfall is there. When cricket fever is going on, there is a table. How many teams are there? How many no World Cup kind of thing? How many matches? IPL is there? How many played? how many points, how many draws, okay, that tabular format. So all these are basically structures. In real life, these are structures. Okay, and that is made by that no media. Okay, so they made that structure the way they want and the way they find that it will reflect the information in a proper way. So these are basically structures in our real. Suppose, just I take an example of a current scenario. Suppose there is a state. I don't have statistics, so I'm just giving you an example. There is a state Bihar. Okay, so many patients are there. Okay, if you want to store this, how will you declare? Char state, right? You will assign Bihar to that. You will store Bihar. Then care total number of patients somewhere 2,580. Then no, that will be int variable. Total number of int total number of days. Int what that total number of discharge patients. Some kind of thing, right? So we have declared these many variables and you have stored the data. Okay, but what is the relation between them? Because these variables, though you have stored, you are able to store, you cannot make an array of that, because one is integer, another is float, another third is character. That is not possible. So you cannot make an array of that. There is a limitation. Because suppose I want to store a birth date. Okay, somebody's birth date is 25th June. Birth date is 25th June 2001, suppose. Right. I want to store this. Hmm? There is one way is to store in string format. Another way is to declare three variables: int b day, okay, that it is date, int month, and int year. Right. So date, month, year, all are integers. All are integers. Can you create an array? No, you cannot create an array. Why? All these are integers. So what is the problem creating an array? Hmm? The problem with creating an array is that if you create an array, you can store data. In first element, you can store birth date. In second element, you can store that what month, and third element you can store the year, because all are integers. So you can declare int birth date array of 3 and store that. Okay, but array is not made for that. Array. So how to define an array? Array is a collection of um, similar data types having same nature. So nature has to be same. The nature of this birth date array, if we declare, it is not same, because first is integer. That is okay. Okay, but what is the nature of that? It is a date. Second, it is a month. Nature is different. Third, nature is year. Though all three are integers, you cannot make an array. So there are many situations where user wants to store data in his own data type, own variable, okay, which reflects as a a bundle of some bundle. So that bundle can be created, a package can be created, and that we call it is the structure in C. So I have talked something about almost 20 minutes on need of the structure. So what will be there? How to declare a structure, how to declare variables, what is the what is the difference between declaration of a structure and definition of a structure, whether to declare a structure outside main function or inside main function, what is the right position of that, how to access structure elements. Students know this, how to access. Use the, I mean, those who have learned C, use the dot operator, access those. Okay, that is okay. There is a new, I mean, there is additional feature, array of structure. Can there be an array of structure? There is a wonderful facility given by the Danish teacher. Then what are features of a structure? And obviously, pointer will be there everywhere. Okay, so there is a structure pointer. I told you, pointer will be there everywhere. It makes its presence consistently in each chapter. So structure pointer is going to be there. Very interesting phenomena. So that is how our this chapter will be comprises of. So need user defined data type. It has to be user must have uh, here user means a programmer. So programmer should have liberty to create his own data type. Hmm? It is like no, if you can recall, uh, if you can recall, so we will see how to declare and define a structure. Hmm? So there is a new keyword struct. Struct is the keyword. Structure is there in C. There is structure in C++ as well, but since C++ adopts object-oriented programming methodology, so rarely structure is used in C++. You can use that, but rarely it is used because structure has got some limitations. But structure is the basis of whole this object-oriented programming technology. So we cannot forget that. Whether we should learn that from inside out. Right? So what is the structure body? What is the appropriate definition of a structure? And is there any size of a structure? So yes, is there any size of structure? Declaration, definition about structures in C. Right? Date. Today's date. Get the habit of writing this way. Right? So I will include file first. Suppose I want to store your information. Okay. Suppose char name, I'll declare 50, right? Then I'll write f name, okay? And char first name, family name, right? So P are there, right? Two strings will be there. Then suppose I have got something like I have maintained that serial number, so I will get int serial number, right? Something like that should be int. Then I will give as long int phone number, right? Then I give care city, right? Suppose int be date, int be month, int be year. Okay. Okay, that's okay. Now I can store data in this format. What is the problem? Why do I need a structure? But I need a structure because this is in a staggered way. Okay, they that doesn't establish relation between. I store here, suppose um, um, a name of particular student. Suppose I store Suma here. Okay. Then her surname, her serial number, her phone number, CT, birth date, birth month, birth year. But there is no connection between them. These are not bind together. Okay. So to bind together, huh? Because this is not the only problem. If I want to create, I want to store information of other student, what I will do? Okay, I will declare variables again, another variable char, first name one, family name one, kind of that. Some mess will be there. Otherwise, no, it is complete. It's very difficult. So what I will do, I will create a structure for this because I want to store this information. So I will create a structure. So I have to create a structure, struct keyword, and I have to give name to the structure. Suppose I give C student, right? As a name. This is PUPENT. Okay. Name of the structure, right? And this will be body of the structure and terminated by semicolon. This is must. This is structure definition. This is a structure definition. So there should be structure members. So I'll put all the structure members inside this. Now this becomes a structure. If you correlate along with that, this thing, uh, Excel sheet, okay, the top row is a structure. Huh? Top row is a structure. So you are telling the Excel software or user as well. You yourself or anyone who is going to use your Excel sheet. You are telling what this column contains, what this column contains, what this column contains. Right? So this is called tag name. Okay? So C student is a tag name. Huh? This is semicolon is must. Huh? And all these are called structure members. The question is how many bytes will be reserved for this structure if I call this program. Hmm? Because whether this program can be compiled. Yes, what is the problem? This can be compiled. Okay. Many students feel that there should be printf, scanf, this, that, variable declaration. Not necessary. Okay. This is compiled and executed. You will not get any output, but No problem. When you execute this program, sometimes they ask you how much memory will be assigned. Okay, when you compile and execute the program, okay, no memory will be assigned. Okay, because structure doesn't take any space in the memory. Okay, doesn't take because it is a template. It is a design. It is an intimation to the compiler. This is my own data type. I may create variables of this my own data type. And when I'm going to create variables, I'm going to store data. So you should recognize that. How you will recognize that? That's why I'm actually informing you, right? So that's this everything you are telling to the compiler. So that is the reason it doesn't take space in a memory. What is the size of the structure? You can write that. Right? So if I write printer size of a size of this structure equal to CMD. You can write here size of you can write C because same rule applies here. C student. Right? What is the problem? student. Student. What is the problem? Student. Do you see any problem? Okay. You have to write struct C student. I'll I will give you why this is required. So what is the size of the structure? 172 bytes. Okay. So this is definitely an addition of all this. The 100, 4, think this is 115 to 3. There is always 150. And 5, 4 integers are there. 4 integer means 16. 16 plus 160, 150. That is 166 and 8. 8 for this. So 172. Right? So in all 172 bytes are there. Suppose I declare one variable char read. Let's see what is the size. 176. What was earlier? 172. What is the possible explanation for this? Does character say taking 4 bytes of memory? No. It should not. Let's change this position. Still it is 176. Okay. See, basically, I'll remove this. This basically is that when structure variable is declared, huh? I mean, the structure is defined. Hmm? There is a mm, in there is called uh, Bit padding is there. Bit padding. It is called bit padding, right? You will hardly you will find addresses as odd numbers, right? So what structure does? It gives uh, uh, some bits or bytes are left unused in that because it doesn't like to be start any variable at the odd addressing system. Rarely you will find that. Okay, so when you declare a character as a variable, okay, even you declare three variables, okay, forget about structure. If you declare three variables as uh, integer, float, and character, or character, integer, and float, it many times it will have that character starts at some um, even number, and even though character takes one byte, okay, that next integer starts at again even number. Okay, so character takes one byte of memory, but and so and if it is starting at even number, even address, integer should start at odd address, but it doesn't happen. Okay, because operating system and compiler does this for its own purpose. Okay, and we don't have control over that, but we cannot complain as well because it is doing its own task. No, memory management after all is a uh, no concern of operating system. Okay, so you should not bother about that. But I just mentioned this because no situation arises. So, and it is good that because of some reason actually I discuss this along with you. This is called a bit padding. Okay, so there are ways to avoid all these things. Okay, but that is out of scope of our syllabus. So what I mean here is this structure is going to take 170. Now, how this is done? First of all, this is done like array structure rather variable takes contiguous memory. So how it is the declaration? Suppose I write struct C student, suppose S1, right? This is a uh, declaration of a structure variable. It is same as no in the earlier all programs you declare variable like int x, right, or float y or char ch, right? There is a similarity. Data type, data type, data type built in. What is this? Derived, install, so derived data type. What is this? Array, derived. So here, see here, this is data type, variable, 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 variable. Now correlate along with this. This is the data type, variable, right? This is the data type. This is your own data type, user-defined data type, right? Which is capable of storing this information. This X is capable of storing integer. Y is capable of storing real number. CH is capable of storing character constant. PTR is capable of storing address of integer. Average is capable of storing 5 float constants. And S1 is capable of storing information of student. So S1 is the name of the variable. Right? Okay. Now, how to, let's check here first again. So, size of structure. This text, obviously, size of structure. Now here it is giving just size of the structure, but memory is not allocated. Here, actually, memory will be allocated, right? And it is contiguous. It is contiguous. How it is that? So it is like this. So this is name. This is name. I mean first name. This is a lot of colors have to be used. Right? This is a family name. Right? What is next? Serial number. So this is serial number. I am showing the picture inside the machine. Right? Right? Okay. Then long int. Then city. Then three more variables. And this whole is right. This whole is x1. So this is not basically an array. This is not an array. Hmm? So this is not an array, but this is how structural members are stored at contiguous memory locations. So suppose this address is suppose 2000, right? Can you see that? I don't know. Suppose this address is 2000, right? Okay. So 2000 plus was how many bytes? 50. Uh, 50 length is there, right? What is the length of that? 50. Okay. So this will be 50, right? This will be 100, right? So those will be internal addresses and so on. This will be 2004, like this addressing system 2004, then whatever plus 8, then 50, like that. Okay. So this now, so this is like array, but not an array because this S1 is this thing what single variable, no, and internally all such variables having same internal variable. So if you declare another variable as a S2, right, the memory will be different. Right? This memory will be different. But since it is a structure, right, pattern will be same. So here is first name of S1, last name of or family name of S1, no? Then that roll number of S1, then everything, lot of phone number, city, birth date, birth month, birth year. So this is again simple. Of S2, right? Of S1. Of, okay, there is of. Okay, this of S1 in English sentence, right? So how to access? How to access? They have given the dot operator. But before accessing, we have to what? We have to store all these things. Huh? So I write printf enter first name, then it is and write s1 dot um, s1 dot first name, right? Instead of taking input, we will initialize that storing because it will take a lot of time unnecessarily, right? So how to not initialize? We'll assign those values, right? Program is quite big, so it will take a lot of time. Now, one thing is sure, have to add something. Hash include string dot h. Have to add that, right? Now, first name is equal to, we cannot write like that. Okay, if you are written this thing, what string programs on string, or if you have tried some codes, sample codes, then this is not allowed in C language. Okay, this is not allowed. uh, you have to use the you have to copy the string. Why? Because first name is the constant pointer, so you have to call strcpy, right, and first name comma str right, then for first name, not first name, s1 dot first name, right? You cannot write like that. and I have to write. Now, rest of the details you can copy that. Copy is not allowed for string. Suppose 105, right? S1 dot phone number is equal to suppose double two double five double six double three four one. I don't know whether it is capable of storing that or not. See that, right? Then where is this? Then I write S1 dot city. City has to be copied again. strcpy S1 dot city, comma. Then S1 dot b date. I do not remember, but I will enter some uh, sample data here. 23 S1 dot b is equal to suppose 5 S1 dot b here is equal to 95, and I can print this now. Printed. So we are storing the data and printing the data, right? So first name print this slash in S1 dot first name. Okay. Lot of typo mistakes might be there because I'm not getting any kind of help here. Printer family name, uh, family name, then percent x slash n s1 dot family name. Sorry. Then printer roll number. I will write something. Right? D slash n s1 dot serial number. Phone number. LD slash n one dot phone number. The city percent s slash n one dot city. The percent d percent d percent d slash n one dot date one dot b one dot right. Let's see. Typos are going to be there. What is this? Right. Student dot C student has no member name first name. Okay. What is this? Oh my god. So far, there are no typo mistakes. That mean comparatively, since that I couldn't include that file correctly, it didn't give me help at no during typing the program. Otherwise, it would have helped me. So can you get this? So this is a first name, then family name, roll number, phone number, city, and birth date. Okay. This is how you can store the data in a structured variable. This is the declaration of variable, right? You can declare multiple variables like other this thing, right? So you can declare multiple variables like struct student c this c c student s2 comma s3 like that you can declare. Okay, declaring multiple variables, right? So s2 will take another 172 bytes, s3 will take another 70 bytes. Okay, and this is just I mean we have not started yet programming. We have just declared one structure, assigned some values, and we are printing that. That's it. Okay, now um, how to initialize structure variable. So initialization has to be done like this. So if I write struct c student s4 is equal to, everything has to be written. What is this? Like this, right? So we have to write suppose Piyush, right? Comma Agarwal. Then what is the next? Roll number, right? Suppose 10. Then phone number. Suppose 445588. And whenever you want to store a long number, assigning, okay, not in the structure anywhere, you need to, like I told you, when you store the float number, attach the F here, attach the L, small L or capital L, right? So that you are telling the compiler this is a long number, not integer. Then I don't know his, I cannot remember his place. Okay, I will write New Delhi. Huh? Then what that? Birth date. So suppose 14 uh, 3 and suppose 2002. This is how it has to be initialized. Initialization. Right? This is initialization. So you can print that again. Hmm? So I can print that. I will change all this. X4, X4. Right? So if I compile this. So how to initialize structure? The sequence has to be followed. Right? So this is the data of Piyush Agarwal. Right? So we have initialized and we have assigned. Okay, lot of things are to be remain there. It is almost 8:15. We will stop here. I will take some questions if there are. Dipti, sir, will it be wrong if I write S1 dot first name? Yeah, it will be wrong. It will be uh, that I taught you, no, that constant pointer that I taught you. What it means that I will show you. If I write a statement like this, S1 dot, right, first name is equal to, if I write like this, right, this statement gives an error. It's not related with the structure. Suppose you declare a array like this, char name, right? If if I write name is equal to, huh? Both these are wrong. Okay, this is wrong. Huh? This is just final. This is just version of this. Okay, here you cannot write first name because first name variable belongs to S1. That's why I wrote S1. But both these are wrong. Why? Because the reason is that this name, since it is a string, right? It is a constant pointer made by the compiler. Huh? So it is like uh, you're changing the uh, base address stored in name. You're trying to change this, okay, which it doesn't allow you. Hmm? What I mean, when what compiler feels is that this is a name internal. I'm showing you internal pointer, right? And this is the memory allocated, right? This name is I'm showing everything internal, okay, on the basis of my understanding, my judgment, my knowledge, okay. Dennis, as far as no Dennis, great Dennis Sitchi is not there. But if he would have been alive, he would have said, no, 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 no. I don't mean this. I mean something different. But our understanding is important, right? Because this is how, because what I am telling you that logic clearly is true, right? So I can guarantee you 99% this is right. Okay. I mean, what I'm giving you information is correct. That is 100%. The visual representation might be little bit here and there, right? So this name, sorry, this is the I told you when you create an array or a string internally base address of that is stored in the pointer created by the compiler having same name, right? So suppose this is uh, address 5056, okay, and 5056 is this address, this point, right, this point. Now when I When I try to write this, now this has been made as the const, right? I mean 5056 has been made as the const, right? So it doesn't, when you try to store this, when you try to write this statement, this, what compiler feels is that Dipti is another string, okay, stored at some location, right? 8086 is a location of that, okay, and you are trying to store 8086 here, it doesn't allow you. Why? Because it has been made as a const. So that's why this is not allowed. This statement is not allowed, right? Assignment. So that's why you need to call the copy strcpy.